Okay, ladies and gentlemen, welcome to the final video of the chapter of salts. Now, today we're going to go through three methods of preparing salts. The first method is known as precipitation. Now, the reason why we are teaching precipitation first is because it is one of the most straightforward methods. Now, what do you mean by precipitation? Now, if you look at the pictures that we have over here, okay, this yellow suspension-like thing, okay, or this white suspension-like thing, or this orangey pink, whatever color you call it, all these are actually precipitates. Okay, in the practical, sometimes we write it as PPT. Now, the reason why these form is because when you add two colorless liquids together, so let's say for example the one with the yellow PPT, okay, so when you add solution 1 over here, alright, to solution 2, what happens is there's a chemical reaction. Both of them will react together, okay, and then what happens is this yellow precipitate will form. Okay, this yellow precipitate forms because it is insoluble. Okay, so what we have learned here is this: precipitation is used to prepare insoluble salts. Okay, remember our solubility table? So let's go through the type of salts which are insoluble. Okay, so we are under the method 1, which is precipitation. So what are the insoluble salts? If you remember correctly, what happens is I have clever student leader, right? So basically all chlorides are insoluble, or rather all chlorides are soluble except for my student leader, which is silver chloride and lead 2 chloride. Okay, so clever student leader, so silver chloride, lead 2 chloride are insoluble. Some of you are asking, how about iodides? Now, iodides and chlorides are the same. So, if silver chloride is insoluble, silver iodide will be insoluble as well. Same thing for lead 2 chloride. Lead 2 iodide is insoluble as well. Okay, now the other category that we have is our stupid little brown cow. Remember the poor cow? Okay, so stupid little brown cow. Little brown cow will be lead 2 sulfate. Okay, little brown, so barium sulfate, and of course our cow, which is calcium sulfate. Okay, and then lastly we have the other category, which is our carbonates. Okay, so all carbonates are insoluble, okay, except SPA. Can you still remember SPA? Okay, SPA. You refer it to sodium carbonate, potassium carbonate, and ammonium carbonate. Okay, so precipitation is used to prepare these salts. Namely, I have 1, 2, 3, 4, 5, and of course the big category of carbonates, F6 phosphor. Okay, so once you encounter these salts, you know that they are insoluble, so therefore we have to use precipitation. So what is the precipitation method? Let's move on. Okay, in general, this is the precipitation method. What happens is I add two solutions. These two solutions in green, they have to be soluble. Okay, so if I were to append state symbols to them, they will both be aqueous, AQ. Okay, so when you add these two solutions together, just like the pictures that you saw before, you're going to form this soluble salt. You're going to form this insoluble salt. Okay, so you appear as a suspension. Okay, something like a it looks like a suspension. Okay, it looks like a suspension, looks like a cloud forming in a solution. Okay, and as a result, you're going to form another solution as well. So this is aqueous. Okay, so just from here alone, you can see that eventually, when I end up with the lower half of the equation, okay, how am I going to separate the insoluble salt from the aqueous solution 3? Okay, this is done. This is over. Okay, so what I'm going to do, how I'm going to separate these two at the bottom? Very simple. If something is solid and it is suspended within a solution, what method do you use? You use filtration. Okay, and in the end, what's going to happen is this insoluble salt is going to end up as a residue. Okay, and this solution 3 is going to end up as the filtrate, okay, which we can discard because it is of no use to us. Okay, so eventually we end up with the insoluble salt over here. Okay, so this is the overview of what happens in precipitation. Let's go into examples so that we know in detail what's going to happen. Okay, so let's start with the example of preparing lead-2 sulfate. So lead-2 sulfate's formula is PbSO4, and remember stupid little brown cow, right? So it is insoluble. Okay, so once we have established as insoluble, we're going to use precipitation method. Now, how are we going to carry out precipitation method? There's a series of steps. Okay, the first step is this. Okay, the first step is we're going to add sodium sulfate solution to lead-2 nitrate solution. Okay, notice the spelling of sulfate should be with an F and not PH. Okay, we're going to add a solution of sodium sulfate, okay, to a solution of lead-2 nitrate. Both are soluble. Remember my SPA. Okay, my SPA salts are soluble and all nitrates are soluble. Okay, I'm going to add these two solutions together, and what's going to happen is lead-2 sulfate is going to precipitate out. Okay, let me break it down for you. Okay, if you write out the chemical equation, it becomes very obvious what is happening here. Okay, I have my two soluble solutions, sodium sulfate and my lead-2 nitrate. It's going to form this solution, sodium nitrate, which is obviously soluble. Okay, because it is both a SPA salt and it is a nitrate, and it's going to form our insoluble salt, which is over here. Okay, this is my lead-2 sulfate. Okay, so what happens here is there's actually an interchange of ions. Okay, this bonding with this, and then this bonding with this. It's like they're swapping seats. Okay, so that's precipitation method, very straightforward. Now, what rule of thumb can we deduce from here? Whenever you carry out precipitation, the rule of thumb is this. Okay, you always use sodium something, and you add it to something nitrate generally. Okay, of course you can use potassium something or ammonium something. In general, this is what you do. Okay, how do you know, how do you fill in the blanks? Very simple, you just look at the salt that you want. In this case we want lead-2 sulfate, right? So this will be lead-2 nitrate. Okay, and then the sodium solution will be sodium sulfate. Okay, why? Because eventually these two are going to come together. It's going to precipitate out of the solution to form your insoluble salt. Straightforward? Yeah? Okay. Okay, so for step 2 of precipitation, you have actually carried out the chemical reaction portion in step 1. Now it's just a physical separation. We want to purify the lead sulfate, so we have to go back to our purification and separation processes methods. Okay, so now what I have is an insoluble salt in a solution. So if I have a solid, I want to separate from a solution, what do? I carry out this simple process known as filtration. Okay, so when you carry out filtration, what happens is the lead sulfate is going to be the residue. Okay, it's going to be the residue. And anything else, because all of them are soluble, right? That's the beautiful thing about it. It's going to be the filtrate. Okay, so after this, we're going to move on to the third step, which is to dry the residue. Okay, before we dry the residue, we have to make sure that any remnants of solution, of reactants that we used before, in this case would be our sodium sulfate and our lead-2 nitrate, is washed away from the crystals. So the beautiful thing is this, I can use a wash bottle, I can just spray distilled water over the crystals. Okay, I can just spray it over the crystals itself, and it basically washes the crystals off of any excess solution. And because the lead-2 sulfate is insoluble, right, it won't dissolve back into solution. Okay, so this is step 3. Okay, and step 4, after washing the crystals with distilled water, what happens is you can either leave the crystals, okay, that we have eventually on the filter paper, so that basically the remnants of liquid can just evaporate off into the air, or alternatively you can dry it between pieces of filter paper. Okay, and that concludes the steps of preparing a salt, an insoluble salt, through the precipitation method.